Welcome to my channel, dear students and all the viewers. And today this is the discussion about, see here, domain and range. And what is the definition of domain and what is the definition of range? First we want to saying that the domain where the function is defined and that region is called the domain. See, if this is the function y equal to f of x, where this function is defined and that region is called domain. Okay, domain, in case of domain, that is the interval of x. For example, we want to introduce some function like x plus 3 is, we can say, is defined when this value x plus 3 is more than equal to 0, and that is x greater than minus 3, and it can be written also, therefore the required domain is, that is x greater than minus 3. But see, in the number line, this is here 1, 2 and 3, this is minus 3 to from this to infinity. So that is actually, it can be written like greater than minus 3 to infinity, or this is a real number such that x belongs to a real number. So this is under minus 3, this is equal to infinity. Okay, so this value which lies the value of x which lies between minus 3 to alpha infinity, and that region is called a domain. As see, in this interval this function always defined. So again I repeat, what is the domain? Where the function is defined, then that region is called the domain. And another word here is range. Range is the interval of y, this is the y, as this function is subject to x. If we want to get x in term of y, x is subject to the y, and what is the interval of y, and that value or interval of y is called the range of this function. Okay, so this is the difference between the domain and range. Now another example I want to introduce to other problem for clear, we want to get here a clear view. So see here, another problem is like f of x, this is under 1 over under root of x minus 2, and this is here 6 x minus 2 or 3 minus x. Okay, so see, this is 1 over this. Okay, that's why 1 by 0 is not defined. So this is defined when x minus 2 into x minus 3 is more than 0. See, in my previous question, there was I taken here is equal to, but this is 1 over that. So if we take equal to, then 1 over 0 is not defined, so we can take equal to 0. So that's why 1 over under root x minus 2 and within the bracket 3 minus x is only this part is more than 0. And see, I want to introduce some basic and easy view to get the interval of that. So see, you draw the number line, and this is, if we take 0, then we got here 2, and this is x equal to 3. Okay, this is not domain. First we find the point. So now this is 1 and this is 2 here, and this is 3. So here are the 3 region. Which region is valid for this function? See, so I want to show which interval is valid for that. If we take this is less than 2, this is greater than 2, this is less than 3 and greater than 3. If we take less than 2, that is approximately, just we take 1.99 something. So if we put here 1.99 something, that is we got here within the bracket is negative. But see, here is positive. 1 minus 1.99 something is positive. So negative into positive. We get here negative. So x less than 2 does not satisfy this region. So we can't take x less than 2. So therefore we take x greater than 2. This is a clear view. This is greater than 2 means 2.1. If we put here 2.1, this is positive. If we put here 2.1 positive, therefore positive into positive we get more than 0. So this is valid point. Okay. So like that you easily take greater than either less than. Okay. So this is the technique. And now and equal to not valid here. So only x greater than 2. If we take x, actually showing that the x more than 2. So it should be x less than 3. Okay. So see 2.9 positive, 2.9 positive. Okay. Okay, you don't take greater than 3. See greater than 3, this is 3.1. This is negative and this is here positive. So positive and negative is less than 0. This is not more than 0. Okay. So this is a clear view. We get here clear view. That is x greater than 2 and less than 3. This is domain. Okay. So again I repeat the solution here. Required domain is x such that x is a real number where x lies 2 to 3. Okay. This is the domain for this function. Now again I want to repeat some point. This is a very important point. Look here. If x lies between a to b, it can be written also. This is called open interval. This is a to b. Okay. These are same. See here, if this is a less than equal to x and less than b, and this called the half closed and half open. Half for the closed interval, and this is look like a third bracket, and there is a comma b, and take here first bracket. This is not a mistake in your book. This is a region written by that. Okay. So it can be also written like, for this is closed interval, here equal to means this is closed. Close is called the third bracket here, a comma b. See here is the open interval. It can be notation by the first bracket, and reverse third bracket is called also an open interval. Okay. So this is here again a, and this is b actually. So it can be written like, this is here first bracket, this is half open, and this is here half close. Or it can be written also this is open interval. It can also written by that. Okay. So very important point. See, this is the written by the greater than less than interval for the domain. Now another point a problem I want to introduce you. See, this is here y is equal to actually x square by 1 plus x square. See, all the real values of x satisfy here. Okay. So all, if we put here 0, 1, 2, 3, 4, 5, each and every value of x satisfy here. So therefore the required domain is x such that whole real number. Okay. So that is whole real number. Now, and this is here the another problem. This is question number 10 of this book. This is y equal to f of x, and this is equal to sine inverse twice x. Okay, students, see here what is the inverse of a function. Look like if you have a value of sine x and that is equal to a, you can take also like this x is equal to sine, transfer to the right hand side. It also written by, this is read as a sine inverse of a. Okay. So this is given here. Let us assume this is as a theta. Okay. Therefore, sine theta is equal to twice x. Okay. And you know, the value of sine theta lies between -1 to +1. See, this is sine theta. Okay, this is sine theta. So divided by 2 implies that this divided by 2. So we got here this is therefore required domain is x such that x is a real number which lies between -half to +half, and for that x lies between -infinity to +infinity. Okay, this is the domain of this function. Now, very interesting point today, and most of the competitive exam always given a question for this type of problem. So see carefully, very interesting point of this class. So this is about the discussion of a domain of a function. See the another point of a domain of a function, this is here. Y is equal to f of x is equal to under root x square minus 7x plus 10. See, this is under root, not a 1 over that. So if we factorize, then you got here x minus 2 and x minus 5. So is defined when x minus 2 and x minus 5 is more than 0 and equal to 0. Okay, x minus 2 and x minus 5 is greater than equal to 0. In my previous discussion of this video, there was some problem like that. This is 1 over that. So 1 over that means 1 by 0, and this is not defined. But here is under root. If we take 0, so this is under root 0. This is actually equal to 0. This is defined. So further we draw the number line here. 1 and 2, this is 2, 3 and 4 and 5, this is 5. So where is defined? So we get here the 3 region. So this is this and this also, and which region is valid for this function. So it is clear view to get here. If we take here less than 2, then we got a little like that. Less than 2 means 1.9. If we put here 1.9, so this is a negative. Put here 1.9, this is also a negative. The negative into negative, their product would be a positive. So it is satisfied. So we take here x less than 2 and with equal to. So that's why touch this point here. Okay, for this, so this region is not valid here. If we take as satisfy the less than 2 here, so you can not satisfy is greater than 2 here. If we take greater than 2, that is 2.1. This is a positive, but this is a negative. So negative into positive, negative. So x greater than 2 does not satisfy here up to infinity. Okay, same as if we take again greater than 5. So greater than 5 means 5.1. So 5.1 means positive and positive. So their positive is product is also a positive. So it is valid for x greater than equal to 5 to plus infinity. So this region can be written also is greater than equal to 2. Sorry, x less than equal to 2. So and to minus infinity and x greater than equal to 5 to plus infinity. Okay, so this is not valid region, so undefined region actually. So these two region also and this region can be written as this is okay. So whole real number denoted by r and subtracted from r this region, so we get there the domain. It also can be written as this. Okay, so very interesting problem. See carefully. Next problem for range. What is range? Where the function subject to y, so this is called the inverse function of x, and where the value of y is defined. Okay, so for example, y equal to sine x, okay, and this is here defined from, x is defined from 0 to pi. This is 0 to pi. You know, the value of sine x is lies between -1 to +1. Therefore, this is y, -1 to +1. Okay, but see, whole region is not valid for that. Given 0 to pi, the domain of, given that the valid region is here 0 to pi, then what is the domain of y? So all sine tan cos, this is 0 to pi. In this region, the value of sine is always positive. The value of sine is always positive. So this is can be negative here. So in place of that, we take the region is that. Therefore, the required range is y such that y is the real number, y, y is valid from 0 to 1. Okay, so this is the range of y. Okay, so next problem, that that is in my book here is number 2. So y equal to x square by 1 plus x square. So first we want to get here inverse function. Actually x equal to the subject to y. Okay, so that's why multiply by this y plus y into x square, and this is x square. Y is equal to, we take common x square, this is 1 minus y. So x square equal to 1 y by 1 over y, 1 minus y. So x is equal to actually under root of y by 1 this. Okay, so is defined when y is greater than 0 and 1 minus y is greater than 0, or y is less than 0 and 1 minus y is less than 0, but y never be 1. If we take this region, this is y greater than 0 and y is less than 0. See what happened in this region. This is 0 and this is 1. If we get here, if we take here y look like 0.11. So see, if we put here 0.11 and if we put here 0.1, so this is the valid region. So we can take this region is a range. So one range. For that, what happens? See, if we take less than, this is, so y less than 0 and this is actually y greater than 1. If we take less than 0, let us assume minus 0.1. Minus 0.1. Put here minus 0.1 is negative, but in this case here positive. Negative by positive is negative. Under root of negative is not defined. Same as if we take more than 1, like 1.1. So this is here negative and this is here positive. So under root here negative. So this is not valid region. So this is actually cross. So range is this. It can be also written by required range, and that is equal to y such that y is a real number and which is lies between 0 to 1. Actually equal to 0 be valid, but 1 not equal to be valid. Under root of y over 1 minus y, and this is, if we get here 1, so this is something by 0 is not defined. Okay, so this is only lies between 0 to 1. So this is your range. Okay, so now I want to proceed the next problem for range. See here, uh, that is here y is equal to 1 over 2 minus cos 3x. So first, you know the domain of cos x is sin x, that is value is minus 1 to plus 1. So that's why you want to get here cos 3x. So see here 2 minus cos 3x, and that is 1 by y. So cos 3x is equal to 2 minus 1 by 1 minus 2 minus 1 by y. We know. So that is cos 3x, and that is lies between minus 1 to plus 1. And this is for 2 minus 1 over this is, okay, see here plus 2. So want to eliminate here plus 2. So we added each and every figure by this plus minus 2 minus 2 minus 2. So see here minus 2 minus 1 minus 2 plus 2 minus, okay, minus 2 plus 1. So this is your minus 3, okay, minus 1 over 1 by y. So this is minus 1, okay, multiply by minus. See carefully what's with the affected this greater than and less than region. If we multiply by minus, so you got here 3. So this is greater than equal to 1 over y, and this is greater than equal to 1. If we take, this is a reciprocal of y, if we write here y, so 3 here is greater than, so we write here less than, so same as less than 1, okay. Okay, reciprocal of that, okay. So this is the range, therefore required range is y such that y is a real number where y is lies between 1/3 to 1, okay. Next problem. See, 1 plus, sorry, y equal to sine plus cos x. Here is different two figures, sine and cos. So we want to apply here the compound angle multiplied by y over root 2 of the each figure, 1 sine x by 1 over root 2 and cos x by root 2. So this is y by root 2 and sine x cos pi by 4, cos x sine pi by 4, sine a cos b cos a sine b, so x plus pi by 4. So you know the sine of some angle is lies between minus 1 to plus 1. So this is here minus 1, 1 over under root 2, okay, multiply by under root 2, okay. So this is your range. Range is y such that y belongs to real number, and that is lies between minus root 2 to plus root 2, okay. And also want to introduce the another problem, very interesting problems, that's why I want to introduce to all of you. So that is for the domain, and here is the two function, addition of two function is given here. So final domain is what for that. So that's why I want to solve this problem and get some idea for solving some domain problem. So this is your function, so is defined when, see this is here 2 minus x, so 2 minus x is greater than 0, Okay, 2 minus x is here greater than 0, but 2 minus x never equal to 1. So if we take here 1, so 1 by something is 1 by 1 by log 1 is 0 actually. So we can take this is and x plus 3 is more than 0 and equal to 0. So okay, so for that, so you get less than 2. And for this actually not 1. So x is less than 2 and greater than 1. Less than 2 and greater than 1. From this region we can write here x greater than 1 and less than 2. And this is greater than 1. For this, x is greater than equal to minus 3 to less than 1. Okay, but x never be 1. In case of 1c, if we x equal to take 1, so log 1 is 0, 1 over 0 is not defined. So that's why you get here the domain. So therefore the required domain is and actually this is either or, not and. So x says that x belongs to real number. In case of this is union in set 3. Okay, this is the final result. Okay, thank you.